clearly audible to all?
Yes.
Okay. So today we will formally start the course, and we'll start with arithmetic portion. And in that we will start with the number properties. Okay. Starting with the number properties, you must have heard of the word real number and a non-real number. Can anyone of you tell the difference between these two?
Real number consists of rational and irrational both kind of numbers.
Okay.
Non-real number is like root over of -1 or something like that.
Yes, exactly. Real number is any number that can be presented on the number line. If you draw a number line, this is 0, this is 1, and in right side we have positive values, in left side we have negative values. There could be fraction, there could be integer, there could be any value on number line. But non-real numbers are those numbers in which we have negative value inside the root, right? And we usually call this imaginary number iota if you don't consider in the GRE, right? So this is not considered in GRE. We will start with the real numbers, and the real number is further divided into two types. One is rational number and one is irrational number. What is the difference between these two? Anyone?
Rational numbers can be expressed as P by Q, and irrational numbers of all numbers that can't be expressed as P by Q form.
So this can be presented in P over Q form, and this can't be represented in P over Q form. One thing, can we have Q as a zero value?
No, not equal to 0.
Anyone else?
No.
In GRE,
No, it's not.
we can never have zero in denominator. That in actual math that is infinity, but that don't exist in GRE, right? So remember, if we have fraction, the value in denominator can never be zero, right? Okay, we will discuss the rational number a bit later, but first discuss the irrational number. Any number which cannot be written in form of P over Q. There are two more conditions of that. That number must be non-terminating and non-recurring. What is difference between these two? Anyone?
Non-terminating means doesn't stop the decimal. After the decimal, doesn't stop.
Yes.
Non-recurring means.
Example pi.
Yes. Okay. So actually, first just discuss what is a terminating fraction. We will discuss these a bit later in depth, but just for now, terminating fraction is any fraction that has either 2 or 5 or multiple of 2 or 5 in denominator. That terminates. Let's suppose we have 2 in the denominator, the result will be 0.5. If we have 5 in the denominator, the result will be 0.2. If we have multiple of 2 and 5, any multiple, this is 1 over 10 and this is 0.1. Actually, the value terminates, right? But in case of irrational number, the value can never terminate, right? This is just an overview. We'll discuss this terminating fraction while in the fraction part. And the other is non-recurring. Recurring fraction are just like, let's suppose we have 1 over 3, that is 0.333. 3 will goes on and on. So we usually show this by bar over 3, right? But non-recurring number are just like, for example, 1.2357 up to so on. There is no repeating pattern. It is not terminating, and this is a irrational number. Okay, so irrational square roots of prime numbers are also irrational. We have 2, we have 3, we have 5, we have 7, and not in some cases non-prime numbers as well. We have 6. These are all non-recurring numbers. Everything is clear till now. This is just an overview. We will discuss all of these in detail. Shall I proceed further?
No, I think it's clear.
Yes. One of you tell about the pi. First tell me, pi is irrational number or rational number?
Irrational.
Rational 72
Rational.
22 by
Rational.
7.
No.
22 by 7.
This is approximate value. This is not the exact value. Exact value is 3.141
3.1416.
up to so on.
But it can
22,
be
listen.
determined.
22 over
Continuous.
7. 22 over 7 is an approximate value. This is not the exact value. Right? Actual value is 3.1415 and up to so on. This is irrational number,
1 for 1.
right? Okay. So now moving to the rational number. A rational number is further divided into two parts. One is integer and other one is fraction. At first we say that rational numbers can be written in form of P over Q, where Q can never equal to 0, right? Now in case of integer, Q became 1, but in case of fraction, Q is any value other than 1, right? Okay, so fraction are like, let's suppose 1 over 2, 2 by 3, 3 by 5, any values like that, which can be written in this form. Anyone of you know a shortcut to, let's suppose we have 2 by 3 and we have 5 by 7. Which value is greater?
2 by 3.
2 by 3.
5 by 7 is greater.
5 by 7.
5 by
One
7
way
is
is to use a calculator, but that is at
2
too
by 3.
much time
5
consuming.
by 7
The
is
quick
better.
way is
5 by 7.
just
No, I
cross
just
multiply
multiply.
these. Listen,
Multiply denominator with numerator. Yes.
just cross multiply these. This is 2 into 7, 14, and this is 5 into 2, 15. The right side is greater. That's why this fraction is greater. Right? In case of
Yes.
whenever you are asked to compare the fraction, or in any case, just cross multiply those, and whichever value is greater, that fraction in actual is greater. Right? So this was about the fraction. Don't worry about these. We will discuss these in depth when we'll move to the fraction part. Okay, so let's move to the integer. Integer is further divided into positive integer, negative integer, even integer, odd integer. These are broad categories and there are much more we'll discuss further. Positive integer are integers that are on the right side of the 0. If this is a line and this is 0, on the right side we have 1, we have 2, we have 3. These are positive integers, right? And on the left side of the number line, on the 0, we have -1, -2, -3. These are negative integers. Even integers are integers that are divisible by 2. We have 0, 2, 4, 6, 8. All of these are divisible by 2. When we divide by 2, the remainder is 0. But in case of odd integers, and these are negative as well, -2, -4, and up to so on. In case of odd integer, we have 1, -1, 3, 5, up to so on. If we divide these by 2, the remainder is always 1. Right? Everything is clear till now? Yes. Even in odd is a very broad topic, and this is we will
I
discuss.
have a doubt. Even
Yes.
in odd integers, -3, -5 will come, right?
Yeah, yes. Positive and negative both will be included. Now one more thing. One is positive integer and one is non-negative integer. What is the difference between these two?
Include 0.
Yes, exactly.
0.
Positive
Zero is-
are the integers on the right side of the 0, but when we talk about non-negative, those are 0, 1, 2, 3 up to so on. In case of positive, that will be only 1, 2, 3 up to so on, right? And now moving to the negative and non-positive. These will be -1, -2, -3 up to so on. And non-positive will be 0, -1, -2, -3, right? Just remember 0 is non-negative, non-positive,
Even integer.
even integer. Whenever you get any question, just pay closely to the what the actual word used in the question, right? Whether that is just a number or integer or positive or negative integer or non-positive or non-negative integer. Just a simple word can change all of the question, right?
Can you please repeat it?
Which part?
Positive and non-negative.
When we talk about the positive integers, if we have a number line, this is 0. On the right side of the 0, we will have positive integer that will be 1, 2, 3, 4, and 5. The only difference is if we consider non-negative integer, we will add 0 in this. All of the positive integers and 0 are the non-negative integers. This is clear now?
Yes.
And say likewise for the negative integers.
0 is always 0. Multiple, divided, anything.
I'm not getting what you are saying.
0 is always positive. 0 is positive and negative both, because of there is no accurate divided or divided multiply, which we can then everything is 0.
Remember one more thing. 0
Uh,
is multiple of every number.
Hmm.
And 1 is a factor of every number.
Yes.
We will discuss this in detail when we will talk about multiple and factor. Just remember 0 is a multiple of every number and 1 is a factor of every number. Right?
So 0 a positive integer?
0
right?
is neither positive nor negative.
Never negative. Yes.
Okay, and
Neither
even number,
positive
right?
nor negative and even.
Yes. Even.
Okay.
Right?
So thank you.
Okay.
Sir, I had a confusion.
Yes.
Sir, how 0 is an even number? I mean, whenever we divide something with 0, we get the answer 0, despite
yes.
we are using a odd number or an even number. So how it's making a difference that 0 is an even number?
Listen. If you divide anything by 0, the result is 0. Right?
Yes.
Yes,
If
sir.
we have to.
Result is infinite if we divide anything by
No. I'm not saying in that sense. I'm saying if we divide 2 by 2, the remainder is 0.
Yes, sir. Remainder.
Isn't it like by definition, the even number is when you divide any number by 2, you get
Yes.
an integer?
And remainder is 0.
Yeah.
We get a remainder 0. And in this case, we are getting a remainder 0. Right?
Yeah.
Yes, sir. Yes, sir.
Okay. So let's discuss something about the nature of a number now. Nature of a number. Right?
Could you please explain how a 0 is the multiple of every number?
I will discuss
Additive.
this. Listen. This is in the premise of the factor and multiple topic. Just keep this question we will discuss when we will move to the factor and multiple part. Right? First, I will explain what are is factor, what is multiple, what is divisor. Then you will get an idea that what is actually meant by this term, right?
Okay, thank you.
Okay. Now let's suppose we have a number line. This is 0, this is 1. On the right side, we have value greater than 1. This is -1. On the left side, we have value less than 1, right? Let's suppose we have any question and we want to test the values, and let's make some cases. Let's suppose our first value lie in between 0 and 1. Between 0 and 1. And that will be the fraction value, right? First considering this range, 0 and 1. Just take any example. Oh yes, I forgot to do this today. Okay. Let's consider a number 1/2, right? That value is in between 0 and 1. What will happen if we increase the power of this number? If we take the square of this number, if we take the cube of this number, if we take the fourth power, what will be the result of that? If we take the
It
square,
keeps decreasing.
this will be 1/4. If we take cube, this will be 1/8.
Decrease.
If we take the 4, this will be 1/16, right? So what actually is happening here, that if we are increasing the power, our value is decreasing, right? So this means x is greater than x square, is greater than x cube, is greater than x4, up to so on, right?
Yeah.
But
Yes.
in inverse, if we take the roots of this number, let's suppose to make things easy, I take 1/4 from the range 0 to 4. If I take the square root of this number, what will be the result? This will be 1/2. If I take the cube root of this number, this will be some value have in denominator 1 point something, and this will goes on. So tell whether x is greater or square root of x is greater.
Square root of x.
Root of x.
Square root of x is greater or cube root of x is greater?
Cube root of x less.
Exactly,
Sorry,
and
greater.
same pattern will move on, right?
But
Okay.
if the power become negative, the value will be greater in the opposite in opposite of the power. If you take suppose for the left side, you can consider the left side. If you consider x square not x square, x to the power -2, then the value will be increased.
Listen. I'm
You
just considering the positive powers now,
Okay.
not negative.
Negative numbers you can't do square root, no, anyway.
Yes, we can't.
Listen, for negative number we can't take even roots, but we can take odd roots. I'm saying that let's suppose you have -8. If you take the cube root of this, that will be -2. But you cannot take the square root of -4, because -2 into -2 into -2 is -8. Getting my point?
Yes.
Okay.
That means when we use even numbers, then we cannot
Listen. Please, one at a time. There is a distraction.
Can you repeat?
You're asking me, or
I mean the second one, square root of x. Can you repeat that portion? Let x equal 1/4. Yes, this one.
listen, we have 1/4, and if you take the square root of this, so I'm taking the what is square root? That is the, if this is x, this is actually power 1/2, right? Now, if we take the square root of this, 1/4 square root, this is actually e, and this is 1/2. And one more thing, if we have in this case we have same denominator but different denominator. So smaller denominator means the value is greater. If this is 4, this is 2, this is greater, you can also check by cross multiplying. This will become 2, this will become 4. So that's why this value is greater, right?
Okay, okay.
Okay. Please mute yourself. There is distraction in the voice.
I guess Elisha Yusuf, please mute your mic.
The host can mute the audience. Please, could you please mute that person? Very
Okay, I will mute all of you. Okay. So that's first was between the range of 0 to 1. Now, again, someone has unmuted themselves.
Nahar Islam, please mute your voice.
Okay. Now, if anyone of you talk, just raise your hand and then I will take the question. Okay. Now, in other range of the value greater than 1. First, we discuss a value between 0 and 1. If I take the value greater than 1. Okay. So let's suppose we have taken any value of x is 2, right? Now, if I increase the power of this, if I take the square of this, this will become 4. If I take the cube of this will become 8. If I take the fourth power of this will become 16. And as you are increasing the power, the value actually increase. So x is less than x square, is less than x cube, is less than x to the power 4. And on the other hand, if we if I consider x equal to 4, if I take the square root of this is 2. If I take the cube root of this is any value less than 2. Doesn't matter whatever the value is. The point is that if you are increasing the root power, the value is actually decreasing, right? So x is greater than square root of x, is greater than cube root of x, up to so on, right? Any confusion in this part? Or shall I proceed further? Okay, once I have done this, then I will take the question. So this one was for this range. Now, if I take the range of 0 to 1, -1, yes, I am muted. Okay. Now the third part. If I take the value between 0 and -1, let's suppose x is -1/2. Now the case will be a bit different, because if I take the listen, I will take the question once I haven't done this with this nature of the number part. Because this is a negative number, if we take the even power, negative power even, the result is positive. But negative power odd, the result is negative. That's why we have to see separate cases for even and for odd, right? Now, if x is -1/2, if I increase the even power of this, if I take the square, this will become whole square, and this is 1/4. If I take the fourth power, this is 1/16, right? Again, if I'm increasing the even power, the value is decreasing, right? Which means x square is greater than x power 4, is greater than x power 6, up to so on. If you notice closely, this is same pattern as in the range of 0 and 1. Okay. Now, if I take the odd powers of this, Again, let's suppose we have -1/2. If I take the cube of this, that will be -1/8. If I take the fifth power of this, that will be -1/32, right? Now, remember one thing, negative, if we consider the positive values, 2 or 3, 3 is greater. But if we consider the negative values, we have few minutes. Okay, if we take the negative values, that's what this is -2, this is -3, the smaller one is greater, right? Using that thing, that concept here, x is -1/2 and x cube is -1/8. If we just ignore the sign, negative sign, the x is greater, but we are having a negative sign, and negative smaller value is actually a greater value. That's why x is less than x cube and x cube is less than x power 5, up to so on. Okay. Now, one more thing in this, as you have said earlier, that we can never take the even roots of a negative number, but we can have a odd roots of negative number. Let's suppose we have x -8. If we take the cube root of this, right, the result will be -2. And if we take the fifth root, the result will be even fifth. That will be a bit more less in magnitude, but overall greater, right? So x is less than 3 power x, is less than 5 power x, up to so on. Right? Everyone is saying something. Okay, let's take some questions. Anyone of you want to ask some question?
Yes, I have a question.
Yes.
I am confused about the cubic root of -8 equal to how it become cubic root of -8 equal to -2. I'm not clear about that.
Listen. First, tell me one thing. What is the answer of this?
-8.
-8. And this is actually the cube root. You are just doing this thing, cube 1/3. Phi is cutting down and you are getting -2. Right?
Yes. But
Yes.
for -4, what about for -4?
We
If
can't
you
take for that. Listen, for -4.
It's for -4. For
You are
-4
saying if I
square.
take x as -4.
-4 and I have to take the square root
No, we
of
can't take.
-4.
We can't take the even roots of
Can you please explain why we can't take it? I
that
am
will be imaginary
confusing
number.
about
We can't do that in GRE.
That is imaginary number, that I he was talking
Yes.
about.
Yes,
And
yes.
even I think -8 root -8
Because
is also
listen.
imaginary number.
If you are taking the, let's suppose we have 4, we take the square root, the result is 2. But we can't have
Yes.
the square root of this and result as a -2. This is not possible.
No, -2, not -2. It becomes
Not -2. Yes.
2i.
This
I
is
think
not
Root of
possible. Yeah, and this is what exactly I'm saying. This is not possible. Right?
2i is imaginary number, na? He's not including
Imaginary number is
that.
not considered in GRE. Okay.
Oh.
That's why I am
Yes.
being confused. I am confused about -8 and -4. I'm not clear till now.
We can listen. First, tell me what is actually meant by a cube root. This is actually, let's suppose we have x.
Power
This
to the
means we have power 1/3. Right? And
1/3.
can we multiply 3 numbers and get -8? 3 same number, yes. If you multiply -2 into -2 into -2. So this made -2 cube is equal to -8. And if you take the cube root of this, 3 will be just cut down with the 1/3 and result will be -2. The point is you can take the odd roots, but you can never take the even roots.
Yes, I
Right?
think I am somewhat clear.
Yes, yes. If we consider x
We can
equal to minus
minus 4, then minus 4,
root
minus 2
over
and minus 2 equal to plus 4.
3.
It can be taken. Yes, I got it.
Oh, very well.
Thank you.
Okay. And we are just left with one more range, that is from less than 1, right? Consider any number. Let's suppose we have -2. Again, we have to take separate case for the even power and for odd power. Let's suppose we have, if we take the square of this, result will be 4. If you take the 4 of this, result will be 16. So x square is less than x power 4 is less than x power 6, right? This is a very simple case. But if we have an odd power, x cube will be -8, x5 will be -32, right? So in this case, x is greater than x cube and x cube is greater than x power 5 up to so on. Okay. Everyone is getting my point? With practice, you can have a firm grip
Yeah,
of
got it.
We got it.
Now, if I give you a question that, let's suppose the question is, x is a number, right? And the situation given is that x cube is greater than x, right? Just read it again. X is a number and x cube is greater than x. One is quantity A. This is quantity comparison question. Quantity A is x square and quantity B is x cube. Now, can anyone of you solve this and tell what is the answer of this? We have discussed.
I think his answer is D.
D.
B greater than 1. A.
Answer D.
Answer D.
Yes, answer is D. But tell the logic behind why this is D.
Because we don't know the number, because it may be
Don't know the
positive,
number.
it may be negative.
Positive and negative number.
Yes, I know this is positive. I'm saying that this value lie in which range? First, tell me which thing. This scenario is satisfied in which range? We have discussed 4 ranges.
Greater than 1 or between -1 to 0.
Greater than
This
1.
could be on. This could be possible only for positive number, not negative number.
Negative -1 to 0 also will satisfy this,
Yes,
no?
there are 2 ranges for this. One is greater than 1 and second one is between 0 and -1.
0 and -1.
This is what we discussed, right, a moment before, right? Now, if we see these 2 cases, if this is greater than 1, let's suppose x is 2. So in our question, this will become 4 and this will become 8, right? So in that scenario, B is greater. This is the first scenario. But if we take the other scenario, if this is, let's suppose, -1/2, right? If we take the square of this, this will become 1/4. If we take the cube of this, this will become -1/8. Right away, this is a positive value, this is negative value, so A is greater. That's why the answer is D, right?
Yes.
There is one more way to solve this question, that is related to the inequalities. Just to give an idea, we have x cube is greater than x, right? If you take x on the left side, this will become x cube minus x is greater than 0, right? Now, if I take the x common, this will become x into x minus 1 is greater than 0. So this is actually a formula. A square minus b square is equal to a plus b into a minus
into A
b,
minus B.
right? So this will become x into x plus 1 into x minus 1 greater than 0, right? Now, if you equate all of these to 0, let's suppose this will become x is equal to 0, first thing. If you equate this is 0, x will become minus 1. If you equate this to 0, x will become 1. There is no need to worry if you don't get there. I'm just giving to idea. We will discuss this in detail by solving the quadratic inequalities. So if we just plot this on number line, 1, 0, and minus 1, the key concept is this is a Wavy-line concept. We will always start with the positive direction and proceed with the negative, then positive, then negative, right? Negative, positive, and negative. Our question is about this thing is greater than 0, and we have these two ranges in which the result is positive. One is greater than 1, and one is between 0 and minus 1. This is very quick way and efficient way. We will discuss this in detail, and right now I'm just giving you idea that there are multiple ways to solve a single question. That is all you need to explore, right?
Would you please repeat the last part?
You must you have heard the sine, you know about sine wave. That is just
Yes,
like
I heard.
that is just like this thing, right?
S curve.
In this the concept is just whatever the intervals is. Let's suppose you have 3-4 intervals. This is A, this is B, this is C, this is the concept is start with the positive direction, positive right, then negative, then positive, then negative, then positive, right? Negative, positive, negative, positive. So whatever the inequality is, if you are asked about the positive, so these two ranges. If you ask about the negative, these two ranges. There is no need to worry. We will discuss this. I am just giving you an idea about this, right? There are some
Yes, got it.
exceptions in this as well. So we will discuss that, right? Okay. So now let's discuss about the, yeah, we have plenty of time. Now we'll discuss about a divisibility rule. This is just about the nature of a number that you must know, you must have idea about when you are putting some value from any range greater than 1, between 0 and 1, less than 0, between 0 and minus 1, and less than minus 1, then what could be the possible answer of that? Because in exam, you don't have enough time to assume some value and to solve that by taking multiple values, right? While practice, if you keep on practicing, you can easily have an idea of these numbers. So you know what value you will take. You can just come with the answer just by taking a single value. Everything is clear till now? Shall I proceed further? I'm
Yes.
counting on you guys.
Sure.
Yes.
Okay. So now we'll discuss about divisibility rules. This is the base. You must know about these rules, right? Now tell me when a number is divisible by 2. When a number is divisible by 2, when the last digit of that number is even, just like we have 2, we have 12, we have 16, we have 200. If last digit is even, the number is
Even.
divisible by 2.
Or 0.
Yes, I've already mentioned that, right?
Yes.
Now, when a number is divisible by 3, let's suppose we have 3, we have 33, we have 27.
Hello. Yeah, if the number is divisible by 3, one is some
There's again noise. Let me mute. I will unmute all of them once I'm done with this. Okay, a number is divisible by 3 when the sum of digits of that number is also divisible by 3. We have 3, 3 is divisible by 3, the remainder is 0, so it's divisible by 3. We have 33, 3 plus 3 is 6, 6 is divisible by 3, so that number is also divisible by 3. Now we have 27, 2 plus 7 is 9, and 9 is divisible by 3, That's why 27 is divisible by 3. The point is just add the digits and divide by 3. If that number is divisible by 3, the number is itself divisible by 3, right? This is divisibility of 3 rule. Now, when a number is divisible by 4, a number is divisible by 4 when the last 2 digits are divisible by 4. Let's suppose we have 124. Let's suppose we have 344. If we have to see last 2 digits, last 2 digits are divisible by 4. 24 is divisible by 4. 44 is divisible by 4. That's why these 2 numbers are divisible by 4. You just have, what doesn't matter whatever the length of the digits are, just consider last 2 digits and divide by 4. If the result is, if that number is divisible by 4, then the whole number is divisible by 4, right? Okay. This is 4. Now the 545 is very simple. If the last digit is 0 or 5, the number is divisible by 5. For example, 10, 15, 55, whatever the number is, if last digit is 0 or 5, that number is divisible by 5. This is a rule for 5. Now for 6, we have to, you should know from 0 to 11. You will see that. For 6, the number must be divisible by 2 and 3, both at a time. Let's suppose we have a number 24. First, see that number is divisible by 2. Yes, the last number is even. The last digit is even. That's why 24 is divisible by 2. And check for 3. The sum of these 2 plus 4 is 6. 6 is divisible by 3. That's why both our conditions are satisfied and 24 is divisible by 6. Now, if we take another example, we have 21. If we just first consider the rule of 3, this is 2 plus 1, this is 3. 3 is divisible by 3, so this number is divisible by 3. But if we see the 2 rule, the last is odd. So in this case, the number is not an even. That's why 21 is not divisible by 6, right? So both condition that the number must be divisible by 2 and number must be divisible by 3, both must be satisfied, right? Okay. Okay, this is for 6. Now this is very interesting for 7. The rule is that, let's suppose, take any example, we had 21. The rule is just double the last digit. We have 1 in this case. 1 into 2, this will become 2, and subtract this from the rest. 2 minus 2, the result is 0. If the result is 0, our result is a multiple of 7, so that number will be divisible by 7, right? Okay. I'm repeating that whatever the number, let's suppose take another example. We have 84, right? Just double the last digit. This will become 8 and subtract from the rest from the earlier. This is 0. If this is 0 or multiple of 7, the number which we are considering is the divisible by 7, right? This is for 7. Now for 8. For 8, we will just consider last 3 digits. If last 3 digits are divisible by 8, the whole number is divisible by 8, right? You just need to consider last 3 digits. Okay, this is for 8. And for 9, this is same as for 3. Just add all of the digits, whatever the digit. Let's suppose we have 27. Just add both of these. 2 plus 7 is equal to 9. If that number is divisible by 9, or in that case, the whole number is divisible by 9, right? Take any example. If 2 plus 7 is 9, 9 is divisible by 9. So 27 is divisible by 9. Take any value. Let's suppose you take 81. This is 8 plus 1, 9. And 9 is also divisible by 9. So both of these are multiple of 9, and both are these are divisible by 9, right? And 10 is very simple. If that number end with 0, whatever the number end with 0, the number is divisible by 10. Now the interesting one and the last one is 11. When a number is divisible by 11. Okay, let me take an example for this. Let's suppose we have a number 121. The key concept is just add the digits at the odd place. This is first place, this is second place, this is third place. So just add the digit at odd place. This is first and third, 1 plus 1, and subtract from the sum of digits at even place. Let's 2. If the result is 0, our result is multiple of 11, the whole number is divisible by 11. I'm repeating that. Sum of digits at odd place minus sum of digits at even place. If the result of this is 0 or multiple of 11, the whole number is divisible by 11, right? Take any example, and for time being, let's suppose we have A, B, C, D. Just to give you example, E, F. This is first digit, second digit, third digit, fourth digit, 5 digit, and 6 digit. You have to just add the digit at odd place, 1, 3, and 5. That is A plus C plus E, and subtract then from the sum of digits at even places, B, D, or F. B plus D plus F. If the result of these is 0 or multiple of 11, the number is divisible by 11, right? Now we'll take the question and okay, now we can ask the question. So speed one at a time.
Could you
Can you
please
repeat 7
explain
and 8?
about
Only one at a time. Yes.
Could you repeat on 8?
Yes, speak.
Could you please repeat for the 8?
For the
8.
Hello.
Number 8.
I want you to recall the rule of divisibility by 7.
For 8 is very simple. For please unmute yourself, whoever is talking. For 8, this is very simple. For 1 digit, you will only 8. For 2 digit, that will be very simple. But the confusion is caused when you have more than 2 digits. When you have 3 digits or when you have 4 digits, you just have to see for last 3 digits. When you have 1 digit, that is doesn't matter. When you have 2 digits, just see though. Let's suppose, just giving you an example, we have 32. We will see if 32 is divisible by 8. Yes. When we have 3 digits, whatever the value is, just divide whole by 8. Let's suppose we have 4 digit, 5 digit, or 6 digit. Just see last 3 digits. If last 3 digits are divisible by 8, the number is divisible by 8. Take any example and see any multiple of 8 having length of more than 5, and just see last 2 digits. If the last 3 digits are divisible by 8, the number is divisible by 8. Take any example, and if you still have confusion, say afterwards. Anyone else?
Thank you very much.
One at a time.
Example for 7.
You are not audible.
Kindly repeat the example for 7 with a large number, at least 4 or 5, 6 digits.
Just, that will be a bit difficult. GRE won't give you any number of length greater than 3 for 7 at least. Just give me example for 3 digits of 7. Any example.
343.
What? 2?
343.
343.
Yeah.
Okay. 343. Okay. The concept is just double the last number. This will become 6. and subtract from the earlier. 34 minus 6, result is 28, and 28 is divisible by 7. So this number is divisible by 7. The thing is, just double the last number and subtract from the rest number. If the result is 0 or multiple of 7, the number is divisible by 7.
Does it hold for like numbers greater than 3?
Yeah, it's hold for every value. Right?
No, I'm saying it holds for greater than
Yes,
equal
yes.
to 1000.
Please repeat your question.
I'm asking this rule. This rule holds for all the numbers like greater than 1000 also, or only for 3-digit numbers?
No, it holds for any value, any length. Doesn't matter. You can take 4, you can take 5. Though I haven't checked for that, but this is generic rule for 7. You can check for 3, 4. But remember, GRE won't ask you about this for any length greater than 3, because that will be too much time consuming. And in exam, you will okay, you won't get any question that will be that much time consuming.